Assalamualaikum. My name is Nordini Izazi binti Aduka. I am final year student from Faculty of Applied Science at University Technology Mara. Today, I will present you about my final project. Title is The Effect of Citric Acid as a Cross-Linking Agent on Ionic Conductivity of Carbon Multicellulose and Polyethylene Oxide Solid Polymer Electrolyte. Okay, first thing first, which is the introductions. Battery actually are energy storage device that have three main components, which is electrodes, electrolyte, and separator. Electrodes have anode and cathode, which is where the electrochemical reaction occurs, and electrolyte, which provide the medium for the ion transports, and lastly, separator, which is to prevent the short circuit. In my final year project, I'm conducting an experiment producing electrolyte. Okay, I'm using carbon multicellulose, which is CMC, and polyethylene oxide (PEO) as a polymer host. Why I'm using CMC? I'm using CMC because it is biodegradable, non-toxic, and water-soluble biopolymer, and the presence of hydroxide and ether and also carbon multigroup in the CMC offer the coordination sites for free ion contributing in the ionic conductivity. And I'm using PEO because it is a synthetic polymer which is widely used in solid polymer electrolyte due to an excellent ion transport because it has a high amorphous content, flexible polymer chains, good dissociation of lithium salts, and synergetic effect with CMC, which is CMC have a highly crystalline structure and PEO have a more amorphous content than CMC. Okay, the purpose statement for this experiment, which is even though I'm using the CMC, have a lot of benefits, it comes also with the challenges, which is it has low ionic conductivity due to high crystallinity. So we propose that the combination of polyethylene oxide, which is PEO as a polymer host, and also addition of citric acid as a cross-linking agent. So both of these will enhance the ionic conductivity. Okay, in the experiment, we have two objectives, which is first to fabricate the SPE solid polymer electrolyte using fixed CMC PEO biopolymer blend as the polymer matrix with the lithium perchlorate LiClO4 as the conductive salt and also varying the concentrations of citric acid as the cross-linking agents. And second is to analyze the effect of citric acid concentrations on the ionic conductivity, structural and morphological properties of the SPE using FTIR, SEM, and EIS. Okay. For the methodology of the experiments, okay, the procedure starting with dissolving 0.7 of CMC into the distilled water 25 ml and stir it for 3 hours at 50 degrees. After that, dissolving the PEO 0.3 in the same amount of distilled water, which is 25 ml, and stir it at 90 degrees. And then after that, combine both solutions until homogeneous. After homogeneous, adding the citric acid, starting with 0.03 gram, and stir it at 80 degrees. And lastly, adding the salt, which is LiClO4, 0.2 gram, and stir it at in 2 hours. And after that, pour the solution into the petri dish and put it in the oven for 24 hours. After 24 hours, peel off the film from the petri dish and put it in the desiccator for the next 24 hours. After that, take the film, peel off and cut into the small pieces and analyze under FTIR, EIS, and SEM. Okay, here we can see the list of samples that I'm doing in this experiment. Okay, here is the result and discussion for this experiment. Okay, first, you can see the physical properties of the SPE film after the experiment is done. Here is the four sample of this experiment. Okay, the first sample you can see the sample without citric acid. We can see the physical properties, which is the film-like paper is rough and brittle. But in the addition of citric acid, we can see the changes of the physical properties of the film when the presence of citric acid. We can see the properties is changes from one sample to another sample when we increase the amount of citric acid. You can see the texture become more stretchy and flexible. Here is the result and discussions for FTIR of a cross-linking by citric acid in CMC and PEO. Okay, from the FTIR result, we can say that we are analyzing at OH, C11O, and COC. We are analyzing 4 samples, which is without citric acid and 3 with citric acid. OH having the significant shifting, so we can say that there is formation of hydrogen bond at OH group. while at COO and COC there is no significant shifting, so it indicates there is no formation of hydrogen bonds. Okay, based on the figure, we can see that the action of citric acid forming hydrogen bonds within CMC and PEO, and when the presence of citric acid is increase the formations of hydrogen bonds. So hydrogen bonds is formations within citric acid, CMC and PEO. Okay, here is the FTIR results in complex section consult at ICO4 in CMC, PEO and citric acid. We can see the shifting at OH, COO and COC. We can see that at OH and C1C have a significant shifting due to the effect of ion plus ions with hydroxy group and carbonyl group. In COO, the effect of Li plus ion bonding with carboxyl oxygen increase the bond stiffness while lowering the COO electron density. But at COC, there is no significant shifting because the less affinity of lithium than hydroxyl and carbonyl group. Okay, here is the result and discussions for the SMR result. There is 4 figures, which is the first figure, the sample without citric acid, and 3 other sample is the increasing amount of citric acid. We go through the first sample without citric acid. We can see the surface, the irregular surface and the crack and void. But the other samples become changes in the surface when the increasing amount of citric acid. The figure at the last, the highest amount of citric acid, you can see produce uniform morphology and there is less crack and voids. So we can say that the structure becomes smooth when there is increasing of citric acid. So I can say that the enhancements of structural of polymer matrix thus improve the physical continuity, enable the ionic conductions in the SPE when increasing amount of citric acid. Okay, here is the last result and discussion for this experiment, which is the EIS results. From the EIS result, you can see the ionic conductivity increase when the increasing of citric acid amount. Okay, for the first sample, which is without citric acid, it has the lowest ionic conductivity because it has a galactic character in the polymer. So, it's reducing the segmental motion and constraining the Li plus motion ion as well. So, it becomes the lowest ionic conductivity. And for the last sample, which is containing highest citric acid, having highest value of ionic conductivity because it has the perfect structure which is optimized the ion transport. We can say that the better ion dissociations, the lower the polymer crystallinity, which efficient the ion transport, which is indicated for the last sample having the highest amount of citric acid. It makes the perfect structure for polymer electrolytes that leads to efficient ion conductions while demonstrating the best combinations of conducting with citric acid concentration. And here is the formula that I'm using to have the value of ionic conductivity. This ionic conductivity equal to T per RB and A. RB value is come from the graph of the EIS of every sample of SPE. Okay, for the conclusions for the experiments, okay, I can say that the 0.09 gram of citric acid obtained the highest value of ionic conductivity, which is 1.6 S per cm. And I can say also the citric acid enhanced the ion mobility by reducing the crystallinity and forming a cross-linking polymer network. And the CMC POLICO4 with optimized citric acid has a potential as an eco-friendly electrolyte for solid-state energy storage applications. My experiments, there is 3 recommendations based on the final project. First, we can test with a different type of salt like LiBF4, LiTFSI to compare the ionic conductivity. But we also can use another alternative like cross-linking agents such as succinic acid for a better mechanical strength. And also, we can investigate new SPE by new polymer matrix blend such as CMC PVA or PEO PVP to further enhance properties. Okay, that's all from me. Thank you.